The Big Bang Theory is the prevailing cosmological model for the universe. It basically explains how the universe began, how space, time, matter, and energy began. According to this theory, the universe started out as a singularity, an infinitely dense and hot point. Then about 13.8 billion years ago, that point expanded rapidly. Wait, what? I'm getting to that. In the first moments, space and time expanded exponentially. This period of rapid expansion is called inflation. After that, the universe continued to expand, but at a slower rate. As the universe expanded, it began to cool. And when it was just 380,000 years old, subatomic particles like protons and neutrons formed. These particles combined to form the nuclei of the first atoms, mostly hydrogen, but also some helium. This is because after the Big Bang, there weren't really any other ingredients for more complex atoms to form. So it took millions of years for the first stars and galaxies to form. Gravity pulled together gas and dust, starting the process of cosmic cook. Since then, the universe has continued to expand, which we can observe today by looking at the light from distant galaxies. Most of the light from these galaxies is redshifted, meaning the light waves are stretched, making them more similar to the red end of the spectrum. This redshift indicates that the universe is indeed expanding, because as the light waves are stretched, the wavelength gets longer and the frequency of the light wave decreases. So if you see a galaxy that is far away, you would expect its light to be redshifted, and you do. But wait, there's more. You can also see that the farther a galaxy is from us, the faster it's moving away. This fits really nicely with the Big Bang model. Today, we know that galaxies and stars continue to form within the expanding universe. But they form differently than they did in the early stages. So what evidence do we have for the Big Bang? First, we have the cosmic microwave background radiation, or CMB. This is heat left over from the Big Bang. It's incredibly cool, mind you, about 2.7 Kelvin or 2.7 degrees Celsius. Second, we have the abundance of light elements, mostly hydrogen and helium. The Big Bang model accurately predicts their abundance, which supports the model. Third, we have the redshift of galaxies, which we already talked about. All of these pieces of evidence fit nicely together to support the Big Bang theory. It's important to note that while the Big Bang theory explains a lot, it doesn't explain everything. For example, it doesn't explain what caused the Big Bang in the first place, or what existed before the Big Bang. But hey, it's a work in progress. Scientists are constantly learning and refining the Big Bang theory. Okay, so why does any of this matter? Why should you care about the Big Bang? Well, it matters because the Big Bang explains the large-scale structure of the universe. It also matters because it connects us to the cosmos. Everything that you and I are made of was around before we were born, and it all goes back to that initial event. We are literally made of stardust.